We keep solving this MCQ by solving number 10 as number 9 and 10 as in the previous section. We solve all the other questions. Before we start solving, I would like to discuss in the previous section. I remind you what is N and what is Z. Now I would like to remind you finally what is Q, the set Q and the set R. Okay. We saw N, and just to review, we saw that N is actually the set of positive integer numbers, and Z, we saw that Z is the set of all the integers number both positive and negative. Now what is Q? Q is called the set of rational rational number, set of rational numbers. Q is the set of rational numbers. In fact, what do I mean by rational numbers? For example, a number, so somebody at the high school, maybe they call it set of fractions. Set of fractions. But what does it mean, fractions? It means, for example, 1 over 3 belongs to Q. It's a fraction, right? Is that clear? Also 21 over 8 belongs to Q. So what is Q? Q is the set of all the number x such that x is equal to some m over some n. Yes or not? With this m, the numerator that belongs to z, and n that belongs to n. Is that clear? The numerator can be positive. So Q is the set of all the existing fractions. Is that clear? So 1 over 3, 1 over 10, 2 over 10. But also, when you have the number 1, 1 means 1 over 1, right? So also 1 is a fraction. 2 typically means 2 over 1. So 2 is a fraction. Yes or not? This means that any natural number is a fraction. So n is included in Q. Doubts? Okay. But also, if I take minus 2 is minus 2 over 1. Minus 3 is minus 3 over 1. So also z, every z is included in, every integer in general is included in Q, right? So what we saw so far, we saw that n is included in z, and z is included in. So it means that what is the biggest set that we saw so far? Q, right? So Q is the set of all the fractions, okay? And the natural numbers are fraction, also integer are fractions. Is that clear? No, because anytime you write, even if you write, the question of my student is why the denominator cannot be negative, because I said n, the denominator belongs to n. Because even if I write 5 over, excuse me, because this pen, even if I write 5 over minus 3, this gives us what? It's like minus 5 over 3. Okay? So always. Doubts? That's why, so you can always move the minus from the denominator to the denominator to the numerator. That's why we say that we say that the numerator belongs to n. Nice. Then what is our what is the next step? The next step is that, okay, but yes, Q is very big, but does it contain all the number that we know? I repeat my question. Yes, Q is very big, but does Q contain all the number that you know? They are unfortunately, there are numbers that you cannot write like a fraction. Is that clear? For example, there is no way, there is no fraction. You see the number root of 2? Root of 2, there is no, the root of 2 cannot be written like a frac. There is no way you cannot find m and n such that this fraction give root of. The same for root of 3. There is no way to write this number as a fraction. Is that clear? What does it mean? It means that root 2 and root 3, for example, does not belong to. There are also number like pi. Pi does not belong to Q. And also E. You know what is E, right? 2.62222 dash dash dash. E does not belong to Q. Is that clear? There are too many. So what does it mean? It means that the Q is very big, but it is something like this. There is the zero below. There is still some spaces, yes or not? But now all this number that does not belong to Q belongs to R. Okay, so not only R contains all the fraction, but it's also contains all the number that cannot be written as a fraction. So R contains all the numbers. Is that clear? So Q is also included in R because R is the set containing all the real numbers. Doubts? So Q is something like this. There are some numbers that do not belong to Q, and R is continuous because it contains all the numbers. Okay? Nice. We remind that, and it was important to remind it. Now let's as we remind it, now we can use it. So let's start by quiz number 9 as we wanted to do. The quiz says that given the set A equal to the x belonging to Q, so x is a fraction, right, such that x is equal to 3 plus 3 over n with some n belonging to n. Okay, and we have the set B, that is the set of x belonging to Q such that x is greater than 2. Okay, nice. What is actually the meaning of A? A is given by two conditions. This is the element of x is the element of A, right? But for x to be an element of A, it should satisfy two conditions. First of all, x should belong to Q. It means, for example, that if I give you something like root of 2, it doesn't, yes or not? X should be a rational number. So it should be possible to write x as a fraction. Okay. Second condition, x should be equal to 3 plus 3 over some n, with n belonging to n. For example, let me ask you a question. Does 5 belong to A? It's a question to make sure that you understood the definition of the set A. Yeah, it's fair that the 5 satisfied the first condition. 5 belongs to Q, right? Because 5 belongs to Q because it is 5 over 1. It's a fraction. Now let's check. Can I write 5 like 3 plus 3 over some n? So is it possible to write 5 like 3 plus 3 over some? It's a question. Yes or not? Can I write 5 like this? It will be very difficult. You can. It's not even possible because for this to hold, 3 over n should be equal to 2. Yes or not? It means that 2n should be 3. Yes or not? And that n should be 3 over. But we want n to be what? We want n to belong to n. So 5 5 cannot be written in this way. Yes or not? We cannot write 5 in this way by taking n into natural. So 5 doesn't belong to A. So this was just to show you what means belonging to A. Let me cancel it. Okay. Nice. We continue by considering the questions. Now, before considering the question, let's try to understand more about the structure of A. So this condition just said that X should belong to Q, right? But the most interesting condition is that X should be equal to 3 plus 3 over n, with n belonging to n. Yes or not? Now, this condition, it tells you that you can see that when n increase, because this means that n will be 1, 0, no, n cannot be 0, that's it. N will be 1, 2, 3, and so on. Yes or not? When n is 1, how much you get? So let's write A. You get 6, right? When n is 2, you get 6 plus 3 over 2, which is 4.5. Right? N equal to 3, you get 3 plus 3 over 3, which is 3 plus 1, which is 4. And dash, 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 dash. You see that we are decreasing, yes or not? But we are decreasing toward what? When n will be infinity, when n is tending to infinity, 3 over infinity gives a tends to 0, right? So the most n become big, the most this stuff, the part 3 over n tends to 0. So this number are decreasing and they are tending, I'm saying tending to, this is tending to 3. Why did I put 3 out? Because we are tending to 3, but we will never reach exactly. We will go close to 3 as much as we want, but we will never reach 3. Yes or not? So there is no 3 is not in the set. Okay? 3 do not belong to the set, to A. But the elements of A tends to 3 as much as they want. Okay? So what do we see? We saw that from that, this is the structure of my set A. From that I got exactly the structure of my set A. Yes or not? It starts from 6, decreasing, so it is some element between 6 and 3. Yes or not? A contains some numbers, not all the numbers, but some numbers between 6 and 3. But what is B? B is just all the number belonging to Q such that X is greater than 2. Pay attention to this condition. So I repeat that B says that the number X should belong to Q first, and X should be greater than 2. Okay? Let me write this better because one should. So we have that X belongs to Q and X should be greater than 2. If you combine these two conditions, I tell you that this one, when the line is continuous like this, we mean R, all the numbers, right? But Q is many numbers, but not all the So Q, this is from 2 to plus infinity, right? So B, it's something like this. So B is something like this, from 2 to plus infinity, but just some numbers. Yes or not? Not all the numbers, because we said that we are just taking number in. Is that clear? So this is so B is not the interval from 2 to plus infinity. B is made by the rational numbers that belong to that interval. Is that clear? So let's go and find. So first, once more, you can easily say that A is included in B. all this number that you have in A are inside B. You agree or do not agree? I remind you that all the elements of A move from 6 and decrease towards 3. So they are all here inside. Yes or not? So if I do, once more, if I do A minus B, I will cancel all the elements of A. Yes or not? If I do A minus B, I will cancel off the element of A. Or if I do A intersection B, I will get A. Why? Because when you have when A is included in B, you remember that the intersection is the set that contain the both, right? As A is included in A will contain the element of B and also contain its own the own elements. Yes or not? So remember that if A is included in B, then the A intersection B will just be A. Okay? And A union B will just be B. Why? Because I represent the stuff here. I told you B is, yes, B is like this. B is from 2 to plus infinity, right? Whereas A is just some elements like this, from 6, let's say from 3 to 6, right? You see that the union of the two stuff, I remind you that the union are the element that belongs to at least one. You see that the element that belongs to at least one start here and end up here. Yes or not? Because all these elements belong to at least one of the sets. Yes or not? So, yes. So, A union, yes, just one, like, yes or not? A union B will be B, but A intersection, you see both the line appear only when we are in A. Yes or not? So A intersection B is A, but A union B is B. Okay? Nice. So going back on the MCQ, we get that A minus B is empty, and it is correct, right? So the answer is A. It's 9A. And the other answer are false because A intersection B is A, not B. A union B is B, not A. A union B is A. No, this one A union B is B, but this A intersection B is A. Right? A union B is the interval. We say that A union B is B, but B is not this interval. It is some B is made by the rational number that stand in that interval. Right? Questions, doubts? No questions. Nice. Okay. We can see E is wrong because the question of my student is why E is wrong. It's clear that A union B, this A union B is B, right? But B is not the interval 2 to plus infinity because B is given like this. B is given by the set of B are just the rational number that start in this, that stay in this interval. So in this interval, we do not take all the numbers that are greater than 2, but we only take what? The rational. Yes. When you take an interval, you are taking all the real numbers because the interval is continuous. Doubts? Okay. Nice. Can I continue by solving the number 10? Okay. Now we have the MCQ. Let K equal to x belonging to R such that the absolute value of 6 minus 7x is smaller than 5. So we have the inequality that the absolute value of 6 minus 7x is smaller or equal to 5. Okay, so what is the we want to solve this in order to get our set, right? Please keep in mind that anytime you have, I will recall this property, if you have absolute value of a quantity smaller than a number, let's call the number m, then this stuff means that that quantity stands between minus m and plus. Okay, this is equivalent to say that. Nice. So given that, and we go back, we can write that 6 minus 7x stay between, it is smaller or equal, right? Yes, minus 5 and 5. And thus we add 6 to, if I do minus 5 minus 6 smaller or equal than minus 6 plus 6 minus 7x smaller or equal than 5 minus 6. Yes or not? You say I added minus 6 everywhere. This will be minus 11 smaller or equal than minus 7x smaller or equal than minus 1. Then we can multiply by minus all the inequality. Okay, this will become 7x, but when you multiply the inequality by minus, you flip the position, so it will become 1 and 11. Is that clear? We now divide by 7 everywhere, so 1 over 7 is smaller or equal than x smaller or equal than 11 over 7. So you see that yes, dividing or multiplying by 1. Is that clear? Okay, so you see that the set is just the interval from 1 over 7 to 11 over 7. If you go back, the answer is A. Okay, yes, but here, so the question of my student is this, let's say, to explain a bit this step. This step means I have 7x, I want to get x, I multiply by 1 over 7. Yes, multiply by 1 over 7, or you say divide by 7 or multiply by 1 over 7. Nice. Yes. Yes. Also. So the question of my student was here, when I said that if we multiply by minus, we flip the position of the boundaries. So even if we divide, we should flip if we divide by minus, we should flip. The answer is yes. Anything you do with the multiplication, you do it with the division. Okay, because the division is just the multiplication of the time, is performing the same as performing the multiplication by just multiplying by the inverse. Okay, so this concludes also this MCQ, and we continue then solving a new MCQ in the next video. Thanks.